Hello and welcome to this lecture on decorators or metaprogramming. Python has these interesting features called decorators to add the functionality to an existing code, and it is sometimes called as a metaprogramming as a part of a program tries to modify another part of a program at a compile time. So before just diving into these decorators, let me get you familiar to some of these basic things that we have already studied in the Python. And first of all, it is about the objects. So everything in the Python are objects, and even they are said to be the classes. So Python's object are basically the instances of that classes. Names that we define are simply the identifiers bound to those objects, and the functions are no exceptions. They are only the object too, but with the attribute various different name can be bound to the same function object. So in the object oriented programming, we had seen that Python has an object, that is everything we have imported here, everything, the module and every attribute behavior that we used are in fact the cases of the object. So we have an object that is bound to that particular classes. So if I just take an example in order to recall you, let me say I'll just define a method over here, and that should be first function, and here I'll just say message, and I'll just print that message. And if I just say print me this message is hello, and I'll say world, if this is the message, and let me just go back here. So instead of this hello message, let me just print this message, because we have just passed message over here as a local variable. And now let me just call this first, that is our hello, and let me say hello world over here, and this is basically the calling this same function. So let me just assign this second with this first, that is our first calling this first method over here. Now let me just say second should be also called now with hello. So let me say hello world again, and what do you think what would happen over here? So let me just save this down first and run it. So let me just save this first and press F5 in order to run. Then you could see when we run this code, both the function first and second function gives the same output over here. Here the name, that is first, which is the first method, and the second refers to same function object. So let's take into the deep that if we just analyze this code, that means you can see the function can be passed as an argument to this another function. So you are just passing as an argument to the another function, that is the whole function, which is first function here. That means function can be passed as an argument to this another function, which is basically the second function over here. If you use this function like you have already studied about map, filter, reduce in Python, then you already know that we have just made use of that in order to make or recall some of the generators and some of the comprehensions, and such function that takes other function as an argument are also called higher order function. So let's take the example of this higher order function which takes the function as an argument. So let me define the function that will be increment function, that will simply add the value of x with unit increment, and let me just say return me with just adding 1 to it. And next method I want to define is decrement method. Here I'll just pass x again, and let me just return just by subtracting with 1. And let me just define now operate method, which is responsible to perform the operation, and this is happening, that is we just pass a function over here. So you can see clearly over here the function is passed as an argument to this operate method over here. So let me pass another argument as an x, and let me just calculate the result, which would be sufficiently the function calling, and basically it would be func of x. So this func is basically either this increment or decrement here, and let me just return that result after we perform that operation, and let me say return that result for me. So you can clearly see we have just passed this function as an argument to this operate method over here. So this type of functions that take other function as an argument are also called higher order functions in Python. So if you just invoke this function, let me just run this app first, and let me say operate method should be invoked, because we have this operate which take this func. So let me say increment. So if I just say increment should be, let me say, with this 3, so let me just pass comma here and the 3, then you could see we get 4 over here. So if I just call again this operate method, but in this case we'll just decrease with this dec function and I'll just pass 3, then you could see we have 2 here. So basically we make use of this method containing your functions is argument to this one complete function. That means we have a higher order function over here. Furthermore, a function can also return the another function. So let's quickly take the example, that is I'll just make is called method over here, and in this is called I'll just say that is a nested function, and we have already studied about the nested function in the case of a closure, which is basically essential or a criteria in order to just support that closure in the Python. So let me say we have a nested function which is returned here, which will just print hello world, and let me just close this down. So after this we'll just return from here, that is from is called method, that is our return is returned. So it is the same function that we have done in the case of a closure. So we make now that is a new variable, and I'll just call this enclosing function which is called. So we have make use of this is called, which is enclosing function over here. So next thing what you can do is we'll just say new. So if you just save this one and just press F5, then you could see hello world over here, which is basically in the case that is function which is enclosing function is returning the another function. So the way that the function can return the another function, or which the local variable is bound to this particular nested function, is the closure in the Python. So it is important to know about the Python, as we have there is returned, which is a nested function which is defined and returned each time we call this is called method. And we have already studied about the closure in the previous lecture, so it won't be any difficult for you, as we have just called this is called, which is outer enclosing function, which basically returns this is returned every time we call this is called or a outer enclosing function over here. So after recalling all of these terms, that is closure and that is about the functions method, how they can be called, now it's time to get back to the decorators. So first of all, let me say that functions and method are callable as they can be called. In fact, any object which implements this special method, and in this case the special method will be call method, and if you know that with the double underscore and double underscore at the end and at the beginning, we just normally call this as a special method, and this termed as a callable. So this method is basically a callable. So in the most basic sense, a decorator is a callable that returns a callable. So we'll just say decorator takes in a function and adds some functionality and returns it. So let's take the example what I'm really talking about. So first of all, just in the theory part, you just have to remember that decorator takes the function for you and adds some functionality and returns the same function. So let's get back to the decorators and define one method in order to say how the decorators is useful in order to add some functionality to our function. So let's say we have this make pretty method, and this make pretty method is responsible to provide the decorators to our ordinary function. So let me say we have inner method here. So you could say we have now here that is the nested function over here, which is inner function, and I'll just print that is I am decorated over here. So we'll just say I am decorated. Now it's time to call this func, and this is basically over here, and we'll just say return, which is basically our inner. So this is the closure over here. So let's define this ordinary function, which is not decorated basically. So we'll just say print me this ordinary function saying that I am ordinary. So we have now made the two function in which we have made the use of a closure in order to decorate, and simply call this I am decorated message. And in this ordinary, you could see this ordinary is a normal function just printing saying that I am ordinary, and you could see here we have this ordinary just saying that I am ordinary over here, which is a normal function. And we have defined this type of function in the previous lectures a couple of times. So what we need to do now is, let me just save this down and run in the console. console. So now it's time to call this method. So first of all, I'll just say ordinary method. So calling an ordinary method is simply with this signature. So it is simply saying that I'm ordinary, which is ordinary function. So let's make the pretty. So in order to decorate this ordinary function which we have here, that is I'm ordinary, and if you want to decorate that I'm ordinary function, you have to just make something like first this pretty. So this pretty should be made with the help of this make pretty, which is our enclosing function. So make sure you just pass the same name over here, that is your make pretty function, and it should be over here pretty. And after you just pass this make pretty, you have to just pass a function over here. So the function that need to be decorated, so the function here would be our ordinary function that needs to be decorated. So let's get back to the console, and let me just pass here ordinary, which is our function which need to be decorated. So that means this func is a function which need to be decorated. So let me just hit enter here, and let me call this pretty now. So if you just call this pretty, then you could see it will just say pretty is not defined, okay, because it should be pretty, pretty. I have just misspelled here as a pretty. That means you just put here pretty, then you could see something like I am decorated and I am ordinary. So that means you have added some functionality to this ordinary function using this decorated and making the use of this closure in order to decorate your ordinary function. So in this example, you could see make pretty is your decorator. So if you see here, this is make pretty and this is for the decorator. Simply it is a decorator, and in the assignment step you can see in this console we made this assignment step to this make pretty, where this ordinary is the function that got decorated and the returned function was given the name as a pretty. So it was decorated and given the name of pretty, which is obviously the new function, and it should be called over here. And if you just call over here, that is with this pretty, and basically it was a typo over here which just made here pretty with a double E. That means I just created the new function, and calling on that new function which is returned by our decorator, it is decorated. So ordinary function is decorated. We have added some functionality, like over here we have printed something like I am decorated over here, and we make use of this func in order to call this normal ordinary function. So in this case what we have done here is func is our ordinary, and basically this ordinary is passed, and after you just print this func was called as an ordinary. So you printed this next line which is I am ordinary over here. So you can clearly see that this make pretty function, which is our decorator function, has added some new functionality to our original ordinary function over here. And this is similar to packaging a gift. The decorator just act like a gift or wrapper, and the nature of this object that got decorated, actual gift inside does not alter. That means this ordinary function does not alter, but now it looks pretty since it is decorated. So the content inside this ordinary is not altered by this decorator, only it is making the new additional of the functionality to this our ordinary function. And generally we decorate a function and reassign it as here, that is calling with this decorator and passing this function which needs to be decorated. And this is basically your common construct. So you make a decorator and you simply just pass the ordinary function in order to decorate it. But Python has another syntax in order to simplify this bunch of code. It can simply make use of annotation in order to make pretty your code. So let me just go over here and let me just define something like @ and let me make pretty. So I'll just say make pretty, and now it's time to run our console again. So if you see here, instead of just returning or calling this func again, what we did was basically we make use of this make pretty, which is obviously our decorator, and we use this @ symbol along with the name of this decorator function, which is in this case make pretty, and place it above the definition of this function, which is ordinary function that needs to be decorated. So we have taken an example like this annotation is given, which is @ symbol, and you just make use of this make pretty and you are good to go. It is same as saying, so let me just write a code. So this is same as saying you just define this ordinary, which is our obviously the function, and inside this ordinary you print something like this same message over here. And let me just copy this one over here, and let me just print it. So it is same as saying that, but the next step would be ordinary equal make pretty. So it is saying make pretty, which is obviously our decorator, and calling with this ordinary. So if you just do this, it is equivalent. If you just do this step, not the whole step, if you just do this step, is equivalent to this step in the case of a Python. So just remember that you can just make use of this syntax in order to do equivalent to this step over here. Now when I just run this code, let's simply save this one and press F5 in order to run this code. And if I just make use of this ordinary call, which is basically our normal function call, it will say I am decorated and I am ordinary over here, which is using only this annotation. So if I just remove this annotation and let me save this one and print again, and if I just say ordinary one more time, then it would say only I am ordinary in this case, because we are not decorating this ordinary. But if we just put this statement, that is the make pretty, which is basically our decorator, above the definition of our ordinary function, let me save this one again and run it one more time. And if I just say ordinary call again, and it should show you something that is I'm decorated and I'm ordinary over here, which is adding the new functionality of this inner nested function to this ordinary using this make pretty decorator over here. So it is the way in order to decorate your function, you just make your decorator function, and inside that you just make use of the function that needs to be decorated, and you make use of a closure in order to return that inner function or a nested function from your outer enclosing function. And you can make use of this instead of just doing something like ordinary, and you just call this same like make pretty, and let me say make pretty, it should be pretty, which is our decorator function, and I'll just pass ordinary over here. So instead of doing this, you can just make use of this. So if I just remove this one and let me save this one more time and let me print it again, then if I just call this ordinary, and you could see we have now I'm decorated and I'm ordinary. So this line, which is basically this line, is equivalent to saying this line. So you can just remove this and provide this simple annotation, and make sure you have same name over here, which is your decorated function. So it's time to now decorate the functions with the parameter. So let's take another example in order to decorate our function with the parameter. So the decorator, which was this example of this decorator, was quite simple, and it worked with the function that did not have any parameter over here, which is in this nested function. So now it's time to check if it works for the parameterized function. So let me say def, which is basically our divide, and I'll just say definition for this divide. Let me say a and b are the argument that must be passed to this divide, and let me say return me a divide by b. Let me save this code and run it one more time, and you could see we have to now call this divide. Let me call with 2 and 5, which is basically a normal division. Obviously it should give you a output as 0.4. let me just divide something like having a divisor that is 0. So let me say it should divide, that is 2, and let me say O, which is basically the B here, which is divisor. So it should throw you an exception saying 0 division error, division by 0 is not valid. So now let's make a decorator to check for this code that will cause the error. So it is really important to make this type of decorator in order to check the case in which we caught this exception, and that needs to be handled. So let's get back to our advanced.py file, and let me just make another function here. Let me just say smart divide, which is the decorator function, and I'll just pass a func here, which is the function to be decorated. And let me just define inner method, which is obviously the nested method that takes a and b in order to just print some masses. And let me say the masses should be formatted like I'm going to divide. Let me say I'm going to divide, and let me say format it with a, and let me say here, let me just give comma over here, and let me just give b over here. Now that we have this masses that should be printed to the user, now let's check if b is equal to 0 or not. So if the b is equal to 0, that means you have to print or give the statement or print the masses that should be, oops, not valid, not valid. So this should be the message if the divisor equals 0, and we'll just simply return from our app. So next is to return that is a func calling with a and b. If it is not the case, that means if it is in the else part, if b is not equal to 0, that means you have to call your function. So function here is our ordinary function. So before that we have to return that is inner, which is nested from this our smart divide decorator function. Now let's create this divide method. So it is the same method that we have created just a moment ago, so that should be a and b, and let me just return with this division a/b over here. So this is our normal ordinary function, it is not decorated. So let me save this one. So before we just run this code, we have to just make this pretty. That means we have to just use the decorators with this annotation in order to make ordinary function pretty, or in order to decorate this ordinary function. So we have already studied in order to make a decoration of this ordinary function, we make use of this syntax. So you can also make use of this syntax, something like divide should be like, let me say, that is using the same smart divide decorator function. It should be smart divide. Let me make a same name over here. It should be smart divide, and you pass that is your divide method over here. So you should pass divide method, and you can just call this divide with 3 and 4 or any value over here, and simply it is same as saying with this code, that is you make use of this annotation over here in order to say this divide, which is ordinary function, is being decorated by using this decorative function. So let's run this app. So first of all, let me save this one and press F5. So first of all, we have to create the divide call. So I'll just say to divide by 5. I need this operation. So it is saying I'm going to divide 2 and 5, which is basically this inner method, and this condition is not valid. That means it will just call this method. That means it will just divide and return us a result, that is 2.5 or 0.4 in this case. And if I just now divide with the divisor, that should be 0. So let me say 2 and 0. So if I just print this down, then it is saying I'm not going to divide, and it is saying I'm going to divide, not, it should be this line, which is inner function call, and it will just check this statement, and in this case b is equal 0. That means we have a divisor that is equal 0, and it will print this oops, that is not valid, and it will return simply. It won't call this divide method over here. So we have made this ordinary function with the use of this smart divide, which is a decorator function. So it basically adds the special functionality to our method. So instead of just doing something like divide, so if I just simply save this one and run this again, and I'll just say divide, and let me say 2, 0, and this is divide is the same method that is not being decorated in this case. So you could see we have thrown an error, or you have raised an error, that is 0 division error, and eventually your app will crash. So in order to just make your app to run better, we have to make use of this decorator, which is basically using this annotation smart divide over here. So this is the way in order to create any decorator function. It is a really easy way. You just need to give the function as ordinary function over here and define your inner method and return, and the way that you just recall or return your inner function is the closure. So you make use of the closure in order to implement this decorator in your program. So this will be the wrap for this lecture. See you in the next one.